At present, please leave your message after the beep.
Dude, Carol, drop that shit.
जो तेरा हाल है वो मेरा हाल है, इस हाल से हाल मिला, ताल से ताल मिला, ताल से ताल मिला।
Leap days do not add tilted 23.4 degrees relative to our spin. It's kind of nauseating at this scale. But from this perspective, you can see that the sun rising and setting is just the Earth pointing you towards and then away from
The
the
number you
sun.
have dialed is not
Okay, this
available
moon
at
is
present.
highest in the sky.
Please leave your message after the beep.
Means pertaining. It will appear as though your will drift, which means adding bodies. Our whole galaxy
Dude,
is
Carol,
also
drop
moving,
that
let's say,
shit.
1,000 kilometers per hour. Our whole galaxy is also moving around the galactic of the bright star clockwise at about 1670 kilometers per hour. Relative to the sun, Earth orbits counterclockwise at 108,000 kilometers per hour along a path tilted 23.4 degrees spin. Within our local neighborhood of stars, our entire solar system is drifting 70,000 kilometers per hour, roughly in the direction of the bright star Vega in the constellation of Lyra. And our solar system is part of a giant galaxy called the Milky Way, on a plane tilted about 60 degrees, approximately like the windshield of a car. universal obstacle course and could travel relatively unencumbered, the universe became transparent light. Since that moment, those early photons have been propagating through space. Every day, they are part of the cosmic microwave background radiation. It is visible in every direction. Microwave shifted of our
Ülker Hanımeller Tuzlu serisi. Keşke şu an kokuyu alabilseydiniz. Zeytinli biberiyeli ve mahlep. İkisi de kıyır kıyır eşsiz lezzetli. Özenle hazırlanmış Hanımeller Tuzlu serisi. Çaylar hazırsa şimdi yemeli. Pardon, Warship evreninden hoş.
into this infinite in the longer aboard spaceship Earth. Okay, now stop. This is roughly 100 movement through space. This path you trace from where we began here is the path you will take through the universe in your lifetime. You didn't buy a ticket for this ride. Your parents signed you up without asking. But nonetheless, it is quite literally the ride of your life. And as always, thanks for watching. Curiosity, picked by myself, been propagated for a long days, approximately like the windshield of a car. Difficult to notice it big, so undid solar year is not a whole number. It's almost 365. But after that many solar days, about a quarter of a day more happens before the solar year starts again. This makes designing a calendar more like designing a calendar over up to a full day after now. A number of day, the famous Western the calendar 5 1/4 solar days don't years is just sure. Right there on the equation throughout the year, and the amount of extra time spent rotating the Earth under the degree to finish a solar day would always be the same. But those two things aren't the case. The Earth's orbit is slightly elliptical, so its speed varies throughout the year. When it's moving around the sun faster around the beginning of January, the amount of extra turning time needed to complete the solar day is longer than when it's further away from the sun. There's more. Because the Earth is tilted, the subsolar point is dragged throughout the year in a circle around Earth that's not the equator, so it changes direction, moving northeast, then leveling out, southeast, leveling out and going northeast again. During times of the year when the subsolar point is being dragged by Earth's orbit mostly east, it gains against Earth's spin faster. More time is required for the day to finish. Now, by coincidence, we are alive at a time when both of these
The number you have
phenomena,
dialed
length
is
and
not available
sunrise,
at present.
is for
Please
everyone
leave your
on Earth
message
as a
after the
useful way what we call course of a year. So throughout the year, they fall ahead and behind the sun.
Dishant Carol,
This
drop
is a
that
solar
shit.
graph, a picture of the sun's path across the sky every single day. If our clocks actually told us local apparent solar time, if you took a picture of the sky every day at noon, you should get a line of suns. But this is what really happened. So some more this sheet of graphics pertaining to noon, when the Greek called so they can easily disappear to you south up moment. Your meridian is just a line from where you are right now. But from this perspective, main head and how don't 21891. Hey, Vsauce! Michael here. On July 1st of 2015, a long-standing ban was lifted. Visitors were finally allowed to take selfies at the White House. This is the first legal selfie ever taken on a White House tour. But a year before the ban was lifted, in February of 2014, I met with the president and secretly took an illegal selfie while on the toilet in the West Wing. Thanks, Obama. Why am I admitting to this crime now? Well, it's time for the truth. Who took the first selfie? Really? Very few people would call this 5 years. One number 100 times. One number. The body. Inside my body to begin with.
100 trillion years from now, the last of a great civilized possibility of calculations that drives entropy to increase. Forgetting information is therefore an essential ingredient for defining an arrow of time. Cold world. And as we continue still into the revolution, time becomes more and more curved as you get closer to the center. Compared to clocks in the simply, there was less space yesterday, and there will be more space tomorrow. Every day. One of the key. First, if you went one step further, what if you were very clumsy, and instead of switching left and right, you switched past? Future. The film now runs backwards. You do run back. Gravitation. Parallel lines there. First sequence of relativity, and there was another property that was completely unexpected. The universe. Quantum mechanics was complicated enough, but after many years of work, But perhaps the solution is simpler than this. Brains, these are concepts that make no sense. There are only their relations. Occurs to you that the air in the room can unexpectely collect itself
The
with
number you have dialed is not available at present.
worrying
Please
thought
leave your
that
message
true
after
something
the
else
beep.
had to give, and the only free thing gave no answers, so physicists began to search for a solution. Perhaps they hypothesized light travels in an invisible medium, a mysterious ether permeating the entire cosmos. But that would also imply an ultimate state of rest in the universe, a worrying thought, as this would break Galileo's relativity. The problem was severe, so whilst one group of physicists set out to measure the properties of this supposed ether, others took the evidence in front of them and made an even larger leap. And chief among these was a young, good experiment thing. But neither. True, something else had to give, and the only freedom in the equations was the very nature of space and time themselves. For it to work, each observer must have their own measurement of space, and each observer must have their own measurement of time. With special relativity, it was the speed of light that was absolute, not space and time. Space and time were no longer the universal stage on which physics played out. And just as Maxwell had combined electricity and magnetism, space-time, too, was about to unite. Gentlemen, the views of space and time which I wish to lay before you, they are radical. Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. In 1908, Hermann Minkowski, Einstein's former professor, came up with an idea. In reaction to the revelations of special relativity in 1905, he had decided to explore the geometry of this new equation. E15 was a solution behind gravity of curved and warped space and time. But there was one more secret to uncover, hidden in the equations. First realized by Alexander Friedman in 1922 and later proved by Edwin Hubble, the expansion of the universe is the expansion of space, expanding which, with unimagined sensitivity, can feel the tiny ripples of space-time. LIGO has opened a new and exciting window on the universe. Which, in 1993, was quite unexpected. With Newtonian gravity, these dead stars should orbit each other. But it turns out that Taylor and Hall's found that the orbits were shrinking, and the stars were slowly but steadily being drawn together. Somehow, the energy of their orbits was leaking out into the universe. And it was then Taylor and Hulse realized Einstein's gravitational waves were an ideal culprit. They delved into the mathematics of general relativity and calculated how the orbiting stars formed ripples in space-time, showing how they could carry away precisely enough energy to explain the orbital demise. In 1993, Taylor and Hulse received the Nobel Prize for their discovery, and 24 years later, the prize was awarded for the direct detection of gravitational waves. That experiment was the Laser Interferometer Gravitational Wave Observatory, or simply LIGO for short, which, with unimagined sensitivity, can feel the tiny ripples of space-time. LIGO has opened a new and exciting window on the universe. They are uncovering merging black holes and the collisions between neutron stars. And now, astronomers even plan to hunt for the oldest gravitational waves, born in the birth of the universe. And so, in this new world ushered in by Einstein, it is clear that the entire cosmos is written in the language of gravity, of curved and warped space and time. But there was one more secret to uncover, hidden in the equations. First realized by Alexander Friedman in 1922 and later proved by Edwin Hubble, the expansion of the universe is the expansion of space, expanding from a single point 13.8 billion years ago, known today as the Big Bang. Put very simply, there was less space yesterday, and there will be more space tomorrow. Every galaxy has been found to be moving further and further away from us, bar our local group, at an average rate of 70 kilometers a second per megaparsec, which actually means that at the moment, for every 3.26 million light-years distance away from us a galaxy is, it is moving away from us at an extra 70 kilometers a second. So, a galaxy 326 million light-years from us is moving at 7,000 kilometers a second, and a galaxy 32.6 billion light-years away, which recedes from us faster than the speed of light. This may seem bizarre after everything we have learned up until this point, but the universe's speed limit only applies to objects moving through space. And these galaxies are not moving through space away from us. Space is simply growing between us. This expanding universe makes curving and bending space-time even more complicated to understand. As equations show that space is infinite, what is actually happening is that the universe is becoming less dense. And clearly, this decrease in density is not completely uniform across the cosmos. We, for example, are not slowly drifting apart. Individual galaxies, too, hold themselves together due to their natural gravity. But as this gravity is a manifestation of the curvature of space, what happens at the boundary between expanding and non-expanding space? And that is not the only problem, as expanding space makes the form of yesterday's space-time different to tomorrow's space-time. thus breaking what was thought to be one of the key properties of the universe: conservation of energy. The importance of symmetry in physics was laid out in detail by mathematician Emmy Noether. Today, physical.
Not sure of your trading style? Copy the strategy of the best. Let top trader.
This is what happens when you exit the matrix. Pay close attention, the end is astonishing. When you are in the process of
You have to remember what the relative... So how can such an arrow emerge from the with time? Analytic Google almost 2 and fully more than grains of sand on a beach.
Hey, this is Michael here, and you guys?
100 trillion years from suggesting that when our universe was strings, and this idea requires that these exotic compounds exist in a heat bath, namely, they are embedded inside stars. So that still doesn't push the clock back any further. There is another possibility, hidden in the dark sector of the universe. All of our understanding of physics, from the table of elements to the fundamental particles, comprises less than 5% of all the energy and mass in the entire universe. Most of the cosmos is of a form probes in the diffuse space, but also nothing. Of exoplanet with 1,000 curious. Life may gain foothold after foothold on countless worlds, only to be snuffed out. Just looking at our own geologic history illustrates the risks that being alive brings. How many times was the Earth almost wiped clean? And that even before the rise of sentience. Once intelligence arose, we developed the capability to destroy ourselves relatively quickly. Perhaps still lack the sophistication to assure our own survival. Proliferation of nuclear weapons and the spiraling disaster of climate change may not threaten us as a species, but it could certainly spell doom. Intact our life across the entire dust. One answer is to force to our rust cooled and oceans form almost isn't believed. Stars currently alive in the Milky Way. Around the topic was still years. There could be multiple species of dark matter particles. Entirely new interactions could take energy beyond years. Lay in some with a soup of chemicals immersed in water. If you on a hunch, she processes the rhythm appear. We aren't sure how these molecules were created on Ryugu, but it likely involved some complex interaction with the sun's ultraviolet radiation, which could have provided the energy needed to turn simple compounds into amino acids. Considering that Ryugu is a remnant from the formation of the solar system and has remained untouched for over these clouds of the planet was still molten. Had oceans, rivers, small dwarf stars have to give rise to our protein structures and all of life on Earth. The experiment had simulated the hypothesized conditions of the early Earth, a warm mixture of what are known as prebiotic molecules. The spark had simulated a lightning strike in a primordial pool, triggering a chemical transformation that will one day lead to life. While we still don't understand the path that led from the prebiotic early Earth, aminobutyric acid, and after a week, the flask was filled with a deep red liquid. After adding additional chemicals to prevent it, make copies of itself, built elements that we're familiar with today. Carbon is exceptionally heavy, experienced roughly the same temperatures that we do today. Though the first life may have been extremophiles, like bacteria that can survive in deep-sea hydrothermal vents, it is still within the broad range of Earth normal. Early life didn't arise in the depths of interstellar space or on the surface of the Sun. Used all the same elements that we're familiar with today. Carbon is exceptionally handy as it combined easily with itself and many other elements, allowing it to form large, strong structures. Oxygen is great for participating in chemical reactions, which means it can serve as a useful tool for storing and later using energy. Phosphorus, nitrogen and hydrogen also play important roles, especially in the construction of DNA and RNA. So perhaps early Earth life would not be so alien after all. The same solvent, the same temperatures, the same elemental building blocks. Those microscopic critters, however they initially emerged, would have the same basic requirements we did: water, food, and energy. But anything off the Earth is a completely different story. It is genetic. We only have all solutions evaluate the most layer. Strange quantum systems could do the trick, or forms of matter not known to us yet. But to begin our exploration of the earliest life, alanine, beta, were amongst the most common molecules in the universe, and are made of carbon, oxygen, a warm mixture. Turning it into on Earth, for whatever reason, the rich on Earth. Experiment revealed the where could that be in the universe? Of course, one place we can be sure of is right here, the surface of the Earth. A planet with an abundance of water and a thick, but not too thick, atmosphere. But our Earth sits in what's called the habitable zone of the Sun. This is a region around a star where the temperature is just right. Closer to a star, the intense heat and radiation will boil away any water, turning it into a vapor. Too far away, and that water freezes into solid ice. Every star don't have its zone, with a location inside that zone depending on the nature of the star. Stars have zones brushing right up against their surfaces. Giant stars have habitable zones reaching hundreds of millions of miles away. The habitable zone of the Sun begins just within the orbit of Venus and extends outwards just past the orbit of Mars. But of the three worlds within that zone, only the Earth maintains liquid water in the present day. And so we can conclude from this small example that the conditions for life as we know it are very strict. With Venus, scientists strongly suspect that it once had a thinner atmosphere and supported oceans on its surface. But as the Sun aged, it steadily grew brighter and hotter. Within a few hundred million years, the intense heat from the Sun triggered a runaway greenhouse effect on Venus, evaporating its oceans and building up a thick atmosphere dominated by carbon dioxide. The conditions on the surface are now so hellish that it's hot enough to melt lead. Mars, on the other hand, is a heavier element, and it's also possible synthesis. This process was discovered in
Sultanlar Ligi isim
Chemistry for
ve
Life.
Türkiye Kadın Voleybol Milli Takımlar ana sponsorluğumuzla
In 2003,
Ay Yıldızı
the
formasının
process
göğsünde ve kadın
dying
voleybolunun yanında
universe.
duruyoruz.
With room temperature radiation. But that was well before the development of rocky planets or even water. And so while we don't yet have a precise answer, we do have limits. The first possibility for life as we know it, swimming in liquid water oceans on a rock, replication and the ability to interact with the environment. Interact. That's only a orbiting a placid star would have occurred somewhere between 100 and 500 million years after the Big Bang. Our own solar system formed some 9 billion years later, and so it is safe to assume the Earth was not the first opportunity for our universe to quit life. cause, that's indicating the kind of life that you can consider no. What kind of life? Imagine. Let's return to our simple definition of life. That which is subject to Darwinian evolution. This requires information storage, self-replication, and the ability to interact with the environment. Life on Earth accomplished this with a soup of chemicals immersed in water, with deep-sea vents or sunlight providing an ample source of energy to drive chemical reactions. And so the earliest life that looks similar to this could not exist for at least a few hundred million years, well after a few generations of stars had already come and gone. But scientists have speculated about many alternative forms of biochemistry. Besides methane, biochemists have also proposed ammonia, hydrogen fluoride, hydrogen sulfide, and silicon dioxide as alternatives to water. Others have proposed that arsenic, which is deadly to almost all life on Earth, might be a useful substitute for phosphorus on some exotic world. Or that silicon, while not as robust and sturdy as carbon, might provide a suitable foundation for complex molecular 7, but something surrounded by the abundant energy of the neutron. The first life in the universe backs microscopic structures inside you after the very core. And the place among these particles, allowing them to form their own periodic table of document. Shadow riders what exotic forces danced in the fires of the Big Bang. Who knows what structures and patterns emerged? Something like life could very well have arisen in that maelstrom, creating, living, and maybe even thinking. Untold generations passing from one to the next, unknown and unknowable to us in their cold and distant future. A legacy erased by the inevitable. The likelihood of nature forbids it. Almost all proves it. So scattered or absorbed. So we may have simply missed the few stray artificial worlds orbiting within the habitable zones of their stars. Every wet world in the galaxy, but that in 14 billion years of cosmic history, we, the first intelligent civilization, quote, is not. Perhaps there are microbes on almost every wet world in the galaxy, but that in 14 billion years of cosmic history, we are the first intelligent civilization to arise in the Milky Way. To beat the astronomical odds, outer moon rates the risks that and the spiral assumes 1.8 billion years old. Our home galaxy, the background, face that dominate the universe, cruelly separate. Rays, even more. It would be a clue, not just to the origins of humanity, but to the origins of all life in the universe. What?
I'm not your sissy, I'm your missy, but we pack kissing one more. Smado. I'm not your sissy, I'm your missy, but we pack kissing one more.
Clic, clac, clic, boom. Comme tu t'appelles, tu as pas mettre neuf tout. C'est une goyo, pour que passe coco, à pas mettre pas venir.
With the man to wanna vale, going a photo. Tu pour chafe, zemra yam semono.
13.8 Freeze out the hadrons choose an identity once and for all. And it is when this happens that the seemingly arbitrary fine-tuned constants of nature releases as much energy as a tradition's finely assembled and anti-hydrogen objectives of the 1 second old universe has lain primarily within the realm of theoretical physics, with our most powerful instruments still struggling to generate the kinds of energies that prevailed within those first then to contract that the universe billion might have been possible. The early cosmos was rife with such trouble. An age before uncharged atoms However, when ambient temperatures dropped to around 4,000 Kelvin, those wayward nuclei were able to combine with each other in a specific order, governed by what's known as their ionization potential. And it is because of this that helium is today considered the most noble of all the noble gases. It is the most inert, and the least likely to react because of the huge amount of energy it takes to strip away one of its electrons and transform it into an ion. But in the early universe, when all that existed were ions, particles with net charge, this supreme grabbing power means that helium was the first element to attract electrons and hold on to them, forming the very first uncharged atoms. However, this stability for helium was sadly short-lived. It was still too hot for lone protons to capture electrons to make hydrogen atoms. So the protons turned to the helium and its balancing complement of electrons, seeking an arrangement where they could share. And so eventually, under the crushing burden of these clingy protons, helium relented, forming the very first chemical bonds and the first molecule in the universe, creating very unstable helium hydride ions in the process. And despite this instability, these short-lived molecules paved the way for the creation of other molecules and the beginnings of space chemistry. Around 100,000 years having passed since the Big Bang. Today, the field of astrochemistry is well developed as the study of what molecules we can expect to find in space and how they form. Many atomic structures that are found on Earth are also common throughout the cosmos, including water and ammonia, while others are much more exotic, like dihydron monochloride. Ions are the building blocks for everything around us. Due to their small size, it takes a staggering under temperatures lower than visible light, sunlight is composed of around 50% infrared radiation, some of which we experience as heat. Even at lower energies, infrared technologies like motion sensors and television remotes send and receive their signals entirely undetected. Bluetooth, Wi-Fi, cellular mobile and GPS all work by exchanging information from the air via microwave frequencies of radiation. While our analog radios and televisions use the longest wavelength of the radiation, radio waves. If we could see all of them, we would be blinded. All told, for all our apparent sentience, we are unaware of at least 99% of what is occurring within the universe. Perhaps this is just as well, as it is hard to imagine how our brains could adapt to cope with all the possible stimuli. The relative calm of a night sky, the blaze of colour and a light of sound, with sharp points of light and song from a multitude of sources. And behind it all, everywhere, a faint backlit glow, remembering radiation, and into math physics governs it's credited for finding or figuring out the cosmic microwave background, despite simulations of life, electrons. Physics holds sway before forces have settled. Close your eyes and imagine yourself within a supervoid.
Nick Fury.
Darkness envelops you, holding you captive and isolated. With your eyes, even with any amateur telescope, you see nothing. No stars, no hint of the fuzzy smudges we now know as our own neighboring galaxies. To you, the universe is empty. The Boötes void is a spherical region 330 million light-years across, approximately 0.2% the diameter of the entire observable universe. The Milky Way could fit inside it millions of times over, and yet within a volume of about 1 million cubic megaparsecs, where there should be thousands of galaxies, we have observed only 60. Spiral galaxies, lit with the light of new star formation. To quote astronomer Greg Aldering, if the Milky Way had been in the center of the Boötes void, we wouldn't have known there were other galaxies until the 1960s. Indeed, were the Earth to rest on one edge of this void, observers on the other side would only now be receiving light from a time when amphibians dominated the Earth, before even the age of the dead. Total and long-lived. Although, for about 200 million years after the Big Bang, the universe contained a baroque fire engine siren to change pitch as it approaches and passes you on the street. As the fire engine approaches, the wavefronts of sound pile up, and we perceive a sound of shorter wavelength or higher frequency. Conversely, as the fire engine recedes, the wavefronts are increasingly spaced out, and we hear a lower pitch. The inherent siren pitch remains the same, but it is the relative movement between the source and the listener that causes a shift. Now imagine a galaxy as our siren, except instead of listening for the sound, we observe the siren light. This light is a specific color, blue, and does not change. As the galaxy recedes from us, however, the light wavefronts stretch out, and we observe a longer wavelength light. The siren gets redder. We call this shifting of the light spectrum redshift. Certain chemical elements are natural siren lights in the spectrum.